under the weather, so this video is going to be pretty short, but transformations aren't, like, super hard either, and your homework's pretty easy or short because the textbook didn't really have a lot of questions like over transformations for me to give you, and I don't know how to create my own on there. So I chose the ones I had. So I just want to go over the rules with you real quick. So transformations are just like, whenever you rotate a shape, when you reflect a shape across different lines and axes and all that. One thing also that deals with transformation is symmetry. So you can have a couple of types of symmetry. You can have reflectional symmetry. And you can have rotational symmetry. And some shapes will have both. So reflectional symmetry is the one we're most used to. Like when you see a shape, can you like cut it up and stuff like that? So like if I take, I don't know, so we can draw some sort of shape, a triangle. Okay, well, a triangle has a couple of, this triangle, a line of reflectional symmetry would be right down the middle right there. It has symmetry. It looks the same on both sides. It's congruent on both sides. Rotational symmetry is like when you can turn an object and it still looks the same. So like it'll have like rotational symmetry. So that'd be like a star, which I don't think I can draw a star, but I'm going to try. See if... Well, pretend that is like a perfect star. Well, anyway, I can rotate this star a certain amount of degrees and it should still look the same if it was like, a perfect star. So you can easily get the angle of rotation by taking 360 and dividing it by how many points there are. So in this case, it would be 5. And that gives us, let's see if I can divide in my head. 9, 5, 8, 7, D. Sorry, I should have divided this beforehand, and now I'm like blanking. 72. So the star would have rotational symmetry, and the angle of rotation would be 72 degrees. So you could rotate it 72 degrees or any multiple of 72, and your figure would still look the same. Now, I just took these screenshots from Google to kind of talk about the rules. So, like reflections, it says reflections are a flip. The flip is performed over the line of reflection. Lines of symmetry are examples of lines of reflection. Reflections are isometric, but do not preserve orientation. So, a reflection, whenever you reflect something across a certain axis, like it's not going to change the size of your shape's still going to be congruent. It's just going to change the orientation, like it mentioned. So you can rotate it across different axes, over the x-axis, over the y-axis, over the y equals x line, and through through the origin. So let's do a little example here. Let's say I have a point at 2, 1. Okay, and I want to rotate that, or reflect it. I want to reflect it. Let's say over the x-axis. Well, I think if you have a picture, like it's super easy to like reflect it over the x-axis because here you have your x-axis. You can just count, it's going to go here. The original coordinates of my point were 2, 1. After I reflected over the x-axis, it's 2, -1. If you look at this rule here, it shows you exactly what's happening. The x-coordinate is staying the same, but the y-coordinate, the sign's changing on the y-coordinate. So those rules are pretty helpful if you don't have a graph to look at. Over the y-axis, the x changes, the y stays the same. Over the line y equals x, the points just flip. So if I have this point 2, 1, and I want to reflect it over the line y equals x, the points just flip. So my new points would be 1, 2. Okay, translations are when you are shifting a point. So you can slide it left, right, up, down. And so this is a rule here where X and K are horizontal shifts. So I like to tell the kids like an X change is a left or a right. And they can remember that because the X-axis runs left and right. And so the Y is an up and down shift because the Y-axis runs up and down. And then, you know, if it's a plus, then it's to the right or up, and if it's a minus, then it's down or left. So if I have the point x, y, and I want to shift it x plus 1, y minus 3, and so I asked, you know, if I was to ask you, like, what direction is that moving in? Well, the plus 1, the x is a left or right shift. This is plus 1. That would be right. So it would be moving 1 right. And then y minus 3, y isn't up or down. And since it's minus, it'll be down. So 3 down. So that rule says that my shape would be moving 1 right and 3 down. So translations are, it's all pretty easy. Nothing like wild. So let's look at rotations and dilations. So dilations are whenever you make a shape bigger or smaller. So those are pretty easy. You just multiply the points by the scale factor. And if your scale factor x is greater than 1, then your shape that you're dilating is going to get bigger. And if your scale factor is less than 1, so like a fraction, then your shape will get smaller. Okay. So if I had a triangle and the coordinate points of the triangle were 2, 1, 5, 4, and negative 2, 3, and like these were my triangle points, and we can plot them. I'm just going to kind of sketch them. 2, 1, 5, 4, and negative 2, 3. If I want to dilate it by a scale factor of, let's say, 2, I would just have to multiply all the points by 2. So A would now be 4, 2, B would be 10, 8, and C would be negative 4, 6. And so then that would be my new point. And then rotations, the rules on rotations are, you know, here they are. So if I have a point here in quadrant 1, I can rotate it 90 degrees counterclockwise, and so my point would end up in this quadrant somewhere. I can also rotate it 270 degrees clockwise, so clockwise would be this way, and it's going to end up in the same spot. So that's why if you look at the rules, it says like counterclockwise 90 degrees, and it's the same thing as clockwise 270, and they have the same rule. So I'm going to go ahead and stop because I'm getting tired of talking. Sorry, I'm not feeling that great. But that is over transformations. And again, the homework assignment is super short. It has 3 questions. If you have any questions, please feel free to say.